I'm very honored and pleased to talk about the melting Arctic and the slightly overwhelming question of what will it mean. So it was a bit of a sleepless night last night, but I will try my best. I'm a doctor at University of Reading in the Center for Polar Observation and Modeling. Before that, I was also at CPON at UCL, and I'm in the Department of Meteorology of the University of Reading, very exciting place. There's another workshop with a researcher from there also. My current project is funded by NERC, and it's part of the larger consortium on the environment of the Arctic, climate, ocean, and sea ice. It's a project led by Sheldon Bacon at the National Oceanography Center in Southampton. So, and the aim is to better understand the coupling between the atmosphere and the ocean in the Arctic region through the very thin layer, but insulating layer that the Arctic sea ice is. And my talk will be slightly biased towards sea ice, which is my domain of expertise. And in the second part, I will talk more about some of the potential implications of the sea ice melting. So, climate is changing rapidly. There's strong evidence that humans have caused most of this temperature increase. But it's quite interesting to see that the temperature anomalies, this is the difference between the temperature between 2000 2009 and the average of between 50 and 80. So the anomalies are very heterogeneous. So there's a strong increase of typically 2 degrees in the Arctic, as opposed to the average of 0.6 degrees since the 50s. So this is called Arctic amplification. So what has really caused that is still debatable. One clear contribution is the so-called Arctic albedo feedback mechanism. So as the sea ice is retreating dramatically, more heat the sea ice is white, okay, and is very reflecting. So when it retreats, it's replaced by oceans that are darker, absorbs sunlight, makes the ocean warm and the environment warmer, melt more sea ice, and there is this loop that is kind of catastrophic and is one contribution to the Arctic amplification. So what this has obviously impact on the Arctic region. By Arctic, I mean the definition of whatever is north of 66 degree north. This is a region where there is a polar summer. So there are a few days in the year where there will be no day or there will be no night. So in this area like this. So in these regions you have Arctic Ocean that is most of the year, and now not in the summer. In the winter definitely covered by ice, so the ocean is frozen. I want to make the distinction between the sea ice, the ice that's on Greenland and the ice that is here. This is a very thin layer in the ocean, frozen ocean, typically 2 meters. These are hundreds of kilometers thick ice in Greenland. So often people get confused and they say, how is it going to disappear in a few years if it's 1,000 meters thicker? So it's very different, Greenland, ice sheets and sea ice. My research focuses on the physical process involving sea ice. So we'll start talking about that, but it's important to realize that the Arctic amplification has already shown signs, important signs. The clearer is the decline of sea ice, I will come back to this, but there are also impacts on glacier retreat, very strong glacier retreat in Alaska throughout the Arctic. Permafrost warming and thawing is another important impact of temperature rise in this region. Less snow, ice, river and lake ice is melting, and also an important and accelerating melting of the Greenland ice sheet. And also ocean surface warming, as there's more heat captured by the ocean is measured to be warming. So, okay. So this is an important thing. Another important thing to realize that the Arctic is not this remote place only for polar explorers, almost a different planet. It's part of our system. It's all part of the same climate system. It's also a place where 4 million people live. There are indigenous population. There is a very large biodiversity, species that are specific, only found in this region. The most famous is probably the polar bear. There are lots of mechanisms that are a myriad of feedback mechanisms that take place. A lot of research is going on. A lot of these things need to be understood. For example, the winds and the ocean current will affect the distribution of sea ice. Here it's shown very small, but from you see it takes a lot of the area. This in turn, the distribution of sea ice will affect feedback on the currents and the ocean, and therefore potentially alter the climate and the weather at even on mid-latitude range. So this is something it's important to realize. And also, more and more, there are commercial interest, geopolitical interest in this region, and with this come a series of risks, oil spills, shipping risks, and so on. And this is something, so human influences the Arctic, and the Arctic can influence the humans back. So this is also something quite important. But it's important to look at it as an integral part of the climate system. And sea ice and the Arctic, these phenomena are now currently in the general circulation model. They will try and capture as much of the physics here. So I'm going to show a quick animation, quick movie, showing the sea ice. This animation was produced to commemorate the 2010 launch of the Cryosat satellite mission, where UK has a lot of contribution, and it shows the September ice extent. So September is the minimum. There is a cycle in sea ice extent between March, where it will reach a very large area, in September. The area covered by sea ice is typically the size of Europe on average, or the United States. And you see here how from 2000, let's try and stop, this was the minimum in 2007. You see that from 1978 to 2007, there's been a reduction of about 40%, so quite dramatic in sea ice extent, leaving all this Beaufort Sea uncovered in other regions. If you continue this animation until 2010, you see that there is internal variability, but overall, the last 6 years have been the smallest extent ever recorded, consecutive years, and 2012 was actually the largest, the absolute minimum. So if I go back to the presentation, normally it was embedded, but it didn't work this time. Just to be complete, often in September you have a big media thing about have we reached the new sea ice minimum? So that's September sea ice extent. These are data from the NSIDC from last year, 2012, the absolute minimum. But you have to realize that in March it grows back to not exactly what it was in the 70s, but close. So the decline in March is not as strong. So often climate change deniers will use that as an example of how the sea ice is not so big deal. Look, it recovers. But this is hiding a lot of the information. In fact, you have to look at the volume of ice. This is just the extent. If there was a thin layer of ice, it wouldn't mean anything. So it's important to keep that in mind. How do models perform? How do the models that Kevin talked about? There's a huge international effort. There's tens of models that are part of this IPCC report that Kevin mentioned starting in the 80s. All this effort tries to capture various things, various components of the climate. Sea ice is a small part of this. And you see that this is a famous plot from 2007, the previous assessment. Observation of September sea ice extent, very strong decrease of the extent. Models, very wide range of values for the sea ice extent. An average that completely misses the trend. So you can say they don't perform so well. The new set of models, as Kelly said, every 5 years or so there are an assessment of the performance of the model. Remember, it's a small part of the model. The sea ice extent for most people is very irrelevant, but for the polar research is quite important. And they do a better job, even if you can say that 2012 they kind of missed the trend. The problem is that this is again the extent, and you should look at the volume. I will come back to this now. Another aspect that shows that models and the physics of sea ice is not so well captured by the models is if you try to predict, there's a game in the community, every year we try to say in June, what's going to be the Arctic sea ice extent. And a series of groups tried that and I think it's now, you can participate, I think. There's also probably for the public, everybody can try. But here is a research group that tried to predict the 2012 minimums, and they all missed it. This was the absolute minimum that you see here in September. They all missed it by at least 10%. So it shows that the physics must be a little bit wrong in the sea ice, at least, and possibly in the way it's coupled with the atmosphere and the ocean. What about this here? This I downloaded this. It's a very strong community, very active community. You can get the data from today. I mean, this is three days ago, and we see the 2013 trend in sea ice extent, kind of close to the 2012 absolute minimum. What's going to happen? We claim that by improving the physics, you can have a better understanding of short-term predictions. This has a different potential interest, commercial, but also for the climate and to try and better understand the climate. So that's what I do. Here I would like to say that there has been a very important breakthrough recently. I mentioned Cryosat. Cryosat 2 is a satellite, European satellite that was launched in 2010 successfully. The first launch was a failure and crashed, but the second was successful, and that's very good because now, for the first time, we have a ice thickness map. So before we were seeing the extent, but now we see also how thick the ice is. This is a scale you can see, I think it's 5 meters, 0 to 5 meters. So just the average is about 2 meters. So it's a thin layer of ice, but very important. And it extends to 88 degrees north. So this is an enormous achievement, and I want to pay tribute to these two researchers that probably you've seen in the news died tragically this year. I used to work with these two guys, and Dr. Catherine Giles and Professor Samuel Lassie, the leading researchers from UCL, and I've really contributed to this work, and some of the work I will show later. And a lot of researchers that work with them pay a lot, need to thank them for their help and their inspiration. So this is going to be a breakthrough in our understanding of how this sea ice thickness has changed and the total volume of it. If you have the area and the thickness, you have the total volume of ice. And this has confirmed the picture that was already understood, that sea ice is shrinking, is thinning dramatically. In the total volume, the Arctic, I told, the extent reduced by 40% from 78 to 2010. The volume has reduced by 75%. So this was also based on experiments from submarines, airborne data, in situ data, and that has confirmed this result. But if you want a full coverage and a trend, you have to go back to the 70s, and your best bet to do this is to take a model. But that's not a GCM, it's a model that assimilates data, so it tries to reproduce as closely as possible. It doesn't try to predict the future, but it tries to capture the sea ice characteristics. And this is a model called Biomass, and it has been shown, validated against observations. And if you follow this trend from the 78, now this is a volume in thousands of kilometers cubed. You see that the volume is decaying very rapidly. So from 78 to now, there's 75% decrease. This is coherent with the observations. And some people, this is more a statistical approach. So this is the trend setters, what they call against the models kind of debate. It was kind of heated debate there was a House of Commons environmental audit last year, and there was a bit of discussion. Some people, modelers, will say this is not right, because the models, if you extrapolate this with the exponential decay or any fit, you see that the ice might disappear in the summer within a few years, so definitely before 2020. While the models tend to predict, the Hadley Center, the Met Office model, have a longer prediction of after 2040. So there is a little gap to bridge there, and part of the answer will come from better representation of sea ice. But it's important to have that in mind that the models are slightly failing in capturing the trend of the sea ice. And I think most models now are aware of it. Oops, what's this now? Okay, the media, that's the last animation. If I can get it. So just to close this picture of the Arctic sea ice melting, I'm going to show this animation. So this is something based on observation, showing again from the 78 to today what has happened to the Arctic. And this is it's not the thickness, but it's the age of the Arctic. So the age, you will notice, very young. Most of the ice in the Arctic is less than 10 years old. There is a lot of dynamics in the Arctic. It's moved around. White regions are older ice, so typically more than 9 years old. This is multi-year ice, ridged ice, thicker ice. And the light blue is first-year ice. So it's ice that has melted in the summer and has grown again in the winter. That's a shame because the end is quite good. It's quite good. I mean, quite bad, actually, quite sad. Yeah. So 2010, the multi-year ice is kind of completely gone, in a sense. You can say, they say Arctic is still there, it's recovered, but depending on what you look, if you look at old ice, it's almost gone already. So partly exported out of the Arctic basin, partly melted. So this is, in a sense, quite worrying. And it's also calling for new physics, because the Arctic sea ice landscape has completely changed. You need possibly to think about new physics to capture this. So this is part of my research. This is the first part ending there, more or less. And now I'm going in more uncharted territory for me. It's the question, so what is the question? What will it mean? What does it mean? It's a bit stressful. It's the future. You have to understand it much better. And Kevin might be better to address this. But generally, and here I will rely a bit more on my notes. This is not my direct research, but I'm in an environment where people talk, and I would love to stop at some point. And that might be part of the discussion with you. Actually, you might teach me more than I can teach you. But generally speaking, the Arctic feedbacks have been summarized. The Arctic, the melting of the Arctic has an impact not only regionally, but is, as I said, the potential to affect the climate in general. So there are 4 strong groups of feedback mechanisms that can affect the climate. Atmospheric circulation feedback, oceanic circulation feedback, ice sheets melting, we're talking about the North Pole, and there's similar things in the Antarctic, and sea level rise feedbacks associated with the melting. And finally, land and marine carbon and methane hydrate feedbacks. So definitely, some of these points, I'm not expert in that, but I try to do a literature review on that. I really recommend this report from the WWF that came out about 3 years ago, and I took a lot of information from them, and from more recent publications. So if you start by the mechanism of Arctic amplification, the decline of sea ice is already a sign of this Arctic amplification. And we already see signs of the increased temperature, as I've shown in the first slide. The climate models predict that this trend is going to continue, particularly dramatically in the winter. So this is the different months of the year, up to 2100. This is an average of all the climate models of the previous assessment. And you see an increase of temperature in the winter of typically up to 14 degrees. And that's the new results from the new models that have been improved from the new CIMIT 5 is the coupled model intercomparison process 5, so that's the current one. You see the trend in temperature in the Arctic, and that's the average of all the temperature increase over the next 100 years. And you see a trend of 0.2 degrees per year. That's 20 degrees in 100 years. There's an enormous increase of temperature in the winter. So that's 4 times stronger than in the summer, by the way. So a very strong winter increase of temperature in the Arctic. And that, of course, is going to have a strong impact on the climate. It's a new feature, a new system in the climate model. It has to have an impact. So that's a lot of interest are interested in that. There are publications now coming up. One that has raised the potential impact of this change on the Western Europe climate and on the mid-latitudes is the paper by Francis in GRL in 2012. The idea is that as you go from a system where the Arctic acts as a refrigerator for the North Hemisphere, which is much colder than the warm mid-latitude. If this is changing, then the pattern and the general circulation of the atmosphere is also going to change. And the way it's going to change is by, there are signs of that, and that's one hypothesis, is that the polar jet is essentially a wind from the west to the east that has this kind of undulating Rossby wave shape. It's going to become more, have a larger amplitude, and the jet will be slower. So this apparently is predicted and is already observed to result in strong weather patterns, including extreme weather events, drought, flooding, cold spells in the winter, and heat waves over Europe. So this is one possible impact of this situation. This is ongoing research, and I welcome any comments on that. Another aspect is the second, so is how the ocean now, the ocean circulation feedback is going to be affected by the melting of the ice and the Arctic amplification. So this is research done by Catherine Giles, and she published this in Nature Geoscience last year. And essentially what we find is that, in the words of Professor Duncan Wigan, head of NERC and lead research of CRISA, he said we are performing the largest geophysical experiment ever in oceanography. Essentially, we are removing the sea ice. The climate system is melting sea ice, and by doing that, we allow the atmosphere to do more work on the ocean and set the ocean into motion. Because you have to understand that the Arctic Ocean is kind of quiet compared to the Atlantic Ocean. The currents are much less strong. is a quiescent ocean. And by doing that, by removing the ice, making the ice thinner, and other things that we are studying, we allow the momentum transfer from the atmosphere to the ocean and a spin up. What has been observed in this paper is that there is strong spin up. So sea level rise in the Pofforzai through the influence of the rotating anticyclonically winds. They're creating through Ekman pumping this sea level rise in the Pofforzai that accumulates about 10% of fresh water will accumulate that. And one question is, what happens if this fresh water, if the circulation changes direction and then is released throughout the Arctic and potentially out of the Arctic basin? Potential importance is if fresh water ends up in the North Atlantic here, then there's a possibility that European Gulf Stream and the European weather might be affected. So this is one direction of research that is quite strong. This is better seen in the next slide. So the question is this melting of the Arctic going to affect what is called the overturning circulation or the thermohaline circulation? This is the general dominant pattern of how the ocean is circulating throughout the globe, and that kind of defines the weather in a sense. It's a very strong, on the decadal scale, it tells you how the weather is going to be. So an important contribution comes from the Arctic region, where strong, warm, saline water comes from the Atlantic. It's the continuation of the Gulf Stream, penetrate in the Arctic Ocean. A couple of minutes. I will try and stop question. 2-3 minutes. And rotates in an anti-clockwise motion through the effect of the cold and fresh input from sea ice and other mechanisms, and it's freshened, goes deeper in the ocean and comes out again from the Fram Strait and the Barents Sea. And if a lot of fresh water comes from increased river runoff, from ice sheet melting, from sea ice melting, but also from the strong reservoir in the halocline. The halocline is 200 meters below the sea ice. There's fresh water. If this becomes available and is brought into this region, it can set up a very strongly stratified ocean with less saline water on top of saline water, very stable, which could prevent these saline currents coming in and affect the Gulf Stream eventually. So this is one direction that could also impact the climate. What Kevin said before is that for the UK, maybe it's not as bad as other people. There's this kind of, it's a terrible thing to say, but it might be wrong. But the climate is less warming. That would be possibly one direction. So, but they could be, these are based on climate simulation. You always have to be careful. One more feedback mechanism before I think I will skip the last one and maybe we can talk about it. It's sea level changes due to ice sheets melting. So that's the other component. A lot of research is going on. Cryosat is going to contribute. And we can measure very precisely how the ice sheets in Greenland and Antarctica are melting and how much they contribute to sea level rise. I think it's very useful to put things sometimes in perspective of the 1 million years. We are very top. We are here in a very warm period. So Sir Brian Hoskins from the Department of Meteorology in Reading would say that we're in a warm room and we put the heating on. It's a bit a dangerous place to be, because if you look, the last interglacial period was 120,000 years ago, so 140,000 years, and it was a bit warmer, 2-3 degrees warmer. But that's where we're tending to. And we know from different studies that if we go there, 2 or 3 degrees warmer in Greenland is going to melt. It's a question of time, maybe 1,000 years, maybe 500 years, depending. Again, there are tipping points, there are non-linearities, so you have to be very careful about what you say. But if this happens, if Greenland melts, it has the potential for 7-meter sea level rise. This is not for tomorrow, but it's good to have the idea of the potential. And Antarctica has a potential for 55 meters. That has never happened within 100,000 years. But here, the sea level was higher. It was about 5-6 meters high. So this is somewhere, the steady state would be that, from our understanding. And recent measure, again from Cryosat, there was a paper very well advertised, very well in the media recently, telling how much the sea level rise has changed to Greenland. It's a few millimeters per year, and people were denying, 1 millimeter per year or 3 millimeters per year, that's nothing. But that's 1 centimeter associated to Greenland every 20 years. Remember that's for the last 20 years where the temperature hasn't risen so much. That's my understanding. So 1 centimeter, add 4 centimeters of expansion of the ocean is 5, multiplied by 5 times, it's already 25 meters of sea level rise on average. And this is not going to happen in the same way everywhere. So even 25 centimeters, and that's a conservative estimate, obviously. So this is something that's very important. And I think I might have to, I've already overrun by quite a bit. So the last one is I'm sorry for those who are very interested in that, but it's marine carbon cycle feedbacks. There's also land carbon cycle feedbacks, and also methane hydrates carbon cycle feedbacks that I don't have time to go into. And finally, there are a few slides on geoengineering and should we consider it. But maybe we can keep this in a kind of discussion, because I know some people are interested in that, but it's not my expertise, so we can maybe discuss it. Thanks. I'm too tall.
Too tall like chair. Go back to the slides if you need to. I understand somebody's taking notes as well. Is there anybody actually doing note taking for this session? Would anybody like to volunteer for that?
Is there a blog spot associated with this, and could this be put up? No, is that too much?
Can I just check that? Is anybody able to take notes for this session? Brilliant, thank you. Just sort of get an idea of some of the questions that were asked.
I could put this presentation on my website.
That'd be great.
Yeah.
Just say what it is.
Yeah. And,
It's my name.
Okay.
Answer to that.
Great.
Can I answer that? Blogspots, Sam Corana, Arctic News, or AMAG Rotterdam.
Okay.
One of the
It would be great if when people ask questions, if they would like to say who they are or where they're from. I think that would, sort of give us an idea. One of the things about coming to a conference like this is great to, pick somebody out and be able to go and have a chat with them afterwards. So let's do that. So can I have some hands for questions? So there's a lady there, man there. Are we going to be all right without a mic? Aren't we? A man and a lady. Okay. Should we take a few questions and then see how we go?
My name's Anne Saxon. I'm my name's Anne
Let's have
Saxon.
can somebody do mic duty at all?
Part of the campaign against climate change. I just wanted to ask if the Gulf Stream altered, is it not a possibility that it would trigger another ice age rather than a warming period?
That is not the trend of the climate models.
Yeah. Shall we take a few questions first?
Ah, sorry.
Yeah. Okay. Yes, just a bit back. Do you want to stand up and ask?
Yes, John Davis. When do you foresee the Arctic sea ice, the Arctic Ocean being seasonally ice-free in September? I would guess before 2020, probably 2015, but it doesn't seem to have started very rapidly this year. Okay, that's okay.
There's
I'm not glad to hear you say it, but the possibility that Greenland ice sheet is gone without current, even with the amount of carbon in the air, Greenland ice sheet is already gone. But you mentioned figures of 7 to 55 meters sea level rise for Antarctica included, and I just wondered how. You obviously disputing that Greenland is gone, but how quickly is that going to happen? Is that predictable or not?
and there's a front here.
Bibina Easterman, co-author of a book which is there on a stand at the bookstore. Now, I'm interested in the amount of carbon which is taken up. Is that more or less in the Arctic? I'm a bit unsure. And is the sea ice also more brittle than just thin?
Than just?
Thin.
Thank you. Okay, so we'll take those 4 questions and let Michelle give a chance to. Sorry if I missed you first time round. Sorry. Take your can I take you next time? On the beginning? Can I take you on the next batch of questions? Sorry.
Can you repeat yours? Ice Age?
I was just, yeah, a sort of mini ice age or
mini Ice Age in that way, okay, I wrote Ice Age.
Gulf,
Okay.
about the Gulf.
So the first question was about the Gulf Stream. Is it going to trigger a new Ice Age? I said that the models, of course, it's not necessarily the right time scale, but my understanding, and I don't have the perfect answer to that, but the next 100 years definitely not. There are non-linearities possibly, but even you have to look at past history. For example, there are strong events that cooled. We are in a warming phase. We are in a warming phase, which is accelerating now. But in this warming phase, there have been events where lakes have been released from I think the Canadian regions and cooled temporarily the system, and the entire Earth has cooled down by a few degrees. But that wasn't definitely an ice age. The periods of ice age are also related to the precession, the rotation of the Earth, the inclination of the Earth. So these are that got their own time scales, which are 20,000 years, 100,000 years, 400,000 years. So I wouldn't say that it could trigger necessarily an ice age, but that's my
perhaps
perspective.
ice age was the wrong word,
Yeah.
but I mean
A cooling. It's a less. It could. That's the prediction is that the temperature increase of some regions is less strong than other regions, but that's not exactly clear. For ice-free predictions, I think this is. I'm a bit in between the modelers and the trendsetters. So this would be like the trend would say, as you said before, 2020. I'm probably slightly closer to that. But the danger with trends is like the stock market. You have no physical explanation. So if the next day there's a crash in the stock market, okay, economists don't have any explanation either. So it's a bit like that. But in physics, we like to have some predictive, physical-based things. So the models, in that sense, beat the trendsetter. But sea ice extent is a particular topic where I think that the physics is a little bit can be improved. So I'm hopeful that we can bridge the gap. So I would say between 2020, 2040, but it's always hard to say. The Greenland, that's typically of the mistake that people do. So try and learn from this. Greenland ice sheet is different from sea ice. So let me show you again. That's you were not listening.
No, I understand the difference between them. What I'm saying is there's already so much carbon in the Kevin was talking about 20 gigatons a year or whatever.
Is it capable of
There's
melting?
already so much there that the ice, we're going back to the Pliocene. The Pliocene is over.
Yeah. So I tried to give some indication on that. So just to be clear, sea ice 2 meters.
Yeah, I understand the difference. What I'm asking
So
is
if that is, you're asking if this can melt. I kind of said that the model prediction says that if the temperature of the Greenland reaches 3 degrees higher than what it is now, it's a bit harder to hit that region because it has its own feedback. This is going to warm by 18 degrees, but that's a bit less. But if it reaches 3 degrees, which is kind of predicted, then we expect over a potential of hundreds and thousand years, the Greenland could disappear. So yes, yeah, but it's not sea ice is we're talking 10 years, 20 years. There we're talking hundreds of years, and that's unless there are non-linearities, which I'm not an expert in answering that. But you are right. That's 7 meters. That contributes to 7 meter sea level rise. Antarctic 55 meters, even probably longer time scale. And I don't know if it's also possible. The carbon intake is the last part of my talk, which I didn't talk about. But my understanding is that the first idea is that the Arctic Ocean is an important global carbon sink. At the moment, it's covered with sea ice, so if it opens up, it might take more. So I put some points here. I again refer to this report from WWF and lots of literature, but I would say it's not my domain, so maybe have a look at that. The sea ice being more brittle, that's definitely my research. I'm studying rheology of sea ice, and yes, there are new rheologies that are called elastobrittle rheology. So you bang on, this is exactly. So it's not only thinning, but by thinning, it completely changes its mechanical properties. So this is a small feedback mechanism. Peter Williams is talking about a sudden catastrophic summer where it goes away. The fact that sea ice becomes more weak might contribute to that. But it has also, it can also have negative feedback. So the ice being more brittle, more fractures, and it can the regions with more open fractures where it can freeze. So it can actually be a mechanism to recover the ice. So it's a bit interesting. It's an interesting topic.
Great, thank you, Michelle. Okay, let's take some more questions. So we've got the man in the front who's already had his hand up before. Let me just and Aaron and the man behind you. Are there any more immediately wanting to speak? Okay, another one. Okay, thank you.
Hello. Would you, as a scientist, talking to, in the main, lay people who want to find out what the implications of what's happening in the Arctic are, would you say that the evidence, primarily from Jennifer Francis, that the slowing down, the weakening of the polar jet stream is the prime factor behind the last 2 years of absolutely atrocious weather occurrences, and that the increased Arctic amplification that we can reasonably expect will only lead to worsening weather conditions as the polar stream weakens. Is that virtually accepted by the scientific community, and which something, and I would imagine the scientific community would want to advise governments about with the utmost urgency? By the way, I'm speaking for a pressure group, a group that applies pressure on this very theme called the Arctic Methane Emergency Group.
Thank you. So, Aaron?
Hi, I'm Dr. Aaron Tyrion from the University of Sheffield. So you were saying that we should expect that the Arctic is going to be ice-free in the not too distant future, give or take 20, 30 years. But so how much extra heat that's currently going into melting the sea ice in the summer are we expecting to start to be absorbed into the ocean as a result of there not being any ice left? So basically the question is, where's that extra heat going to go? And as a second part of the question, if you grant me that the ice does melt sooner than the models are predicting, so more in line with the trends, how do you think that would affect the model predictions? And I guess, again, what I'm trying to ask here is, can we really trust the IPCC modelling efforts if the ice is gone in 2015 to 2020 rather than in 2040? Thanks.
And the man
Hi Michelle, I'm David Wasdell from the Apollo Gaia project. We put our study on Arctic dynamics onto the web just 48 hours ago, so I'm sorry it didn't get to you in time to be taken account of. So basically this is about resources that I'm bringing alongside you today, and the copies of the report we put up, which I think you had access to only last night, I'm sorry, are available on the bookstore. There's enough to go around most of the people here. Particular issues, I think the pace of Greenland melt, models in our study in history has tended to look at them in the light of orbital changes. But the pace of Greenland ice melt may be much faster than it's been in history in the light of the rapid change and rapid forcing that we're applying today, which has never happened before. So I think that's a question to look at deeply. And the consequences of the jet stream meandering onto our food production is profound. So could you say something about the implications for food stability as a result of change in the Arctic? And I will make these available for you.
And one more at the front here.
Yes, Simon Norton, member of the Campaign Against Climate Change. Can you just say how relevant are the campaigns by groups like Greenpeace against oil exploration in the Arctic to the problems faced in the Arctic?
Right, thank you.
So it's getting tougher. Round two is, you might defeat me in round two. So ice 320, yeah, this was particularly tough question. Maybe we can talk, because you asked for numbers or something.
Just
so
take
restricted.
a picture for now.
Yeah, but how much extra heat, where does it go? So So my guess is it goes in the ocean, but I think we should discuss more, especially if in the field we could keep in contact with. And the second question is, can we trust the models? That is a, yeah, so.
If it did go into the ocean, would that start leading towards a year-round ice-free Arctic? I mean,
the models predict winter melt also by 2000. The current models predict definitely by 2100, possibly before. The winter is melting also. If you have 18 degrees more in the winter, it's bound to have an impact. So,
if you have all the extra heat in the oceans, is that going to stop the refreezing? Or delay it and then delay it again?
Yeah, that's my understanding. That's one of the feedback.
So it could be much sooner if it happens.
It delays the onset of the freezing and it extends the melting season. That's my understanding. The second part is, can we trust the model? They get something a bit wrong there. You have to understand that the model, as I said, sea ice is a very fragile component. Imagine 2 meters over thousands of kilometers. So, and there are experiments where you take the sea ice out, then cool the system, artificially cool the earth. It grows back quite quickly. So it is a funny one because it is at the same time a bit like a thermometer. And how much an active contributor it is. My guess it is an active contributor, but how much it is I still haven't understood completely, I have to say so.
Have they done the opposite experiment where they've taken out the sea ice and seen how much it increases?
That's something that they have done, but I'm not sure they have done in the way I would like, because you can do, we can talk about that. That's something I would like.
Yes.
Sorry.
It's a bit more technical. So, these are definitely good questions.
I think what I would like to achieve, if possible, is to give us some weapons really to take out there, because we're people who are interested in climate change. We're having conversations with other people.
There's definitely for laymen and actually for scientists, it's a very actual topic, and now there are blogs, there are Twitter. If you're interested in the topic, you could follow it on Twitter. A blog that comes in mind is Neven, N-E-V-N. This guy is I don't know if he's an academic, but he's a like journalist, and he's very active, even for us academic. Of course, it's a bit dangerous. You have to go back to the paper, peer-reviewed. I don't necessarily agree with peer-reviewed, but that's I don't know if that's the kind
in
of
terms of what we can make most important to take from what you're saying to us, and how we can communicate that more generally.
Okay.
Really, yes.
So.
So if you
It's a
can
bit my
reiterate
weakness.
some
I mean, I'm the opposite. I'm the opposite of
Come on.
Kevin. I've got 3 years experience. I'm completely, I'm the silent scientist, but maybe I don't agree that it's a good thing. It's actually can be a bad thing. A silent scientist sends the message that nothing is fine. So I'm not the best example to tell how. The take-home message, I will leave my presentation, is sea ice is melting quite quickly. That's the prediction of the models. And I try to give scientific thing. Beyond that, I need to work on my, I'm not like Kevin. Follow Kevin, I mean, he's a
Are
great
there some
guy.
other questions here that we
So, I have to answer, so maybe I can stick with the same thing. Just to ask, it's your question.
Well, no, can I say, the second part of the paper I'm leaving out has got 9 areas of impacts and consequences, which may help to flesh out some of the issues you're raising.
There are great reports. I mentioned one, WWF. I'm sure you're kind of interested, but these are a good starting point. I mean, if you read very clearly. The resources, you asked about the resources. Again, my work is not at that level of precision, the political, and I'm sorry, I cannot really answer that. But of course, Kevin was quite convincing. If the climate is 8 degrees up, I'm sorry, I cannot answer specifically, but predicted to be a very problematic situation. I can't say for political, but yeah, I need to learn myself. Ice melt Greenland more rapid. Again, you were saying the increase is very quick. Maybe there are other mechanisms that will melt it faster. I don't completely disagree with that. But there are also, it could be slower, so there are different mechanisms that are in the literature. Some say that it doesn't happen if there's more melting, maybe it's slowing down the rate. It's a good research topic to see. It's a very, production I cannot answer. And Greenpeace oil exploration. There's been this environmental audit committee, again a very useful report talking about the protecting the Arctic. There's always a risk with these groups calling themselves risk research, because the risk is a two-sided. So risk means that you are worried, but it also means that you give a legitimacy to something. So I would say this report reads quite well, and Greenpeace and so on. Again, go back to the report, and there's a clear risk if there's an oil spill under the Arctic, this frozen sea. There's no way we can clear this mess. It's going to spread around. It's going to freeze, spread around the entire Arctic. It's a mess. There are other risks with AMEG. They say that drilling can have risk even for human lives, explosions, a lot of risks. And I'm not an expert, but definitely have a look at this report. And there is a commercial interest. So there are people. I know some companies have ruled out. I think Total. I don't know if it's a political stance, but they say we're not going to do drilling in the Arctic. And others are just going ahead. So definitely keep an eye.
Was there a question about jet stream and some of the effects we're seeing as well?
That was part of the crop and which I cannot really answer.
Okay, great. Okay, we've got a couple more questions then, I think, maybe.
Yep.
Hello, I'm Brenda Pollack from Friends of the Earth. So I've got two questions really. One is, when I've been in conversation online with climate skeptics, everything I say and quote and put links to about climate change is happening, they will come back and say, here's some more references, usually from the Global Warming Foundation, but sometimes elsewhere, you know, and they combat everything and say, you know, scientists are also saying this and questioning, you know, the trends. So any help on that, where, you know, a definitive answer would be nice, or a place where, you know, every government has said it is happening or something, as well as scientists. And then the other thing is, coming back to what you were saying, the other thing that Friends of the Earth gets accused of is being, you know, if we're too negative and too scaremongering, quote unquote, people shut their ears and don't listen and don't want, you know, don't know what to do, and bury their heads in the sand if they believe it, or just stick their necks out and argue with you if they, you know, if they don't believe it. So what I would like to know is there anything science can offer to sort of inspire us in terms of new science that's coming about that can combat some of what you've been talking about? Thank you.
And Martin, I don't know if you want to come over and shout.
Martin Empson from the, I'm actually the treasurer of the trade union group, so I do want to thank people for coming. I think Michelle has had an incredibly difficult task here actually, and I really thank you for your presentation, because actually, if you think about the way the media portrays the question of climate change, the Arctic ice is the key thing that everyone sees. It's the image that we see every September, the graphs and so on, and it's the question that everyone asks. And the problem is there's no real way to answer the question, what will this mean? It's very difficult to say to someone in Birmingham or in Manchester, where I'm from, or London, this is what will happen as a result of this ice disappearing. The only way we can answer it is to talk in generalities, but those are quite worrying ones, because we can talk about the consequences will be more global warming, accelerated global warming, more uncertainty, and more extremes in terms of weather. And I think that's the way we have to approach this question. That, you know, it leads us into a discussion about what climate change is, what global warming will mean, and how it will impact us. And I think what the presentation shows is, by understanding what's causing the ice to melt and why the world is getting warmer, we start to see some of the solutions. And I think really that's the answer for us. It's the only real solution is to reduce dramatically the amount of carbon dioxide we're putting into the atmosphere, and start to find ways of finding alternatives. So I thank the doctor for coming here and sort of entering the den. But actually, I think there are some wonderful books and publications out there that people should start to read, because this is increasingly going to be the question that is at the forefront of people's minds. And it's going to be one that activists and environmentalists and trade unionists have to be a bit up to speed on to understand, really, because the impacts will be quite fast, and they are happening already with the extremes of weather. So thank you for coming very much and answering people's questions.
So yeah, I find, because I've started being more involved with the environmental aspect and tweeting and so on, and they are very tenacious. I mean, it's their job, I think, or their hobby, but they can be very tenacious and also very typically I find that they give you a link, and even for somebody who's in the field. I read, for example, recently there was this dispute of, okay, Arctic sea ice has been declined, but look, in the Second World War it was also not there, it was declining. And pages and pages of argumentation and books, a bit weird weird setup, and, and they're not peer reviewed and so on. But still, if you want to spend time looking into this, it takes time, and it takes ages answering to all your questions. So I think you have to keep a bit calm and answer what you know, and try and occasionally spend your weekend destroying an argument if you can, because sometimes they might be more scientifically minded than you, and things like, it's a bit dangerous. You mentioned scaremongering. If you go on TV and say, okay, the ice sheet, Greenland ice sheet is going to melt in 5 years, I think it's counterproductive, because it's a wrong message. It's completely wrong. So you have to. It's like in politics. Don't say completely crazy things, because it's going to backfire. But then I think, I mean, maybe I don't have much experience, but the talk before was quite illuminating. It's more of a political stance. It's an idea you want to have, and you have to also say it's an idea. It's backed by science, but there's also politics. It's not all science, it's politics. So that's one point I would say. And the second point, yeah, how to convince somebody from Manchester that sea ice is important. Again, it's politics. It's a question of idea. It has no. As I said, you can also argue that England might be better off. I don't think it's true, but if you look at some predictions, or Russia. So the guy from Manchester might say, "Wow, that's good." So, but if you have to convince him that people dying in Bangladesh is important, so that's politics. It's not science.
Okay, I'm going to call a halt to things now. Thank you so much, Michelle.